Yes, the number of trials to get the first success. It's a different N, and sometimes they call this one K. Yeah. I like N better for that one, but some people use K, so that doesn't seem like the same N. Okay. So this distribution also has a mean. Its mean is 1 over P. So the average number of rolls it's going to take me to get a 5 is going to be 1 over 1/6, which is how many? 6. Okay, so the mean of that distribution comes in handy sometimes. The standard deviation, I don't know that I've ever used, but it does have a formula: 1 minus square root of 1 minus p over p squared, or square root of 1 minus p over p with the square root. I guess I should write that out mathematically correctly. There we go. And yeah. So now we also have a cumulative function. So if I want to know the probability of it taking more than how about 8 rolls to get a 5? Oops, too far, sorry. There we go. Okay, so probability that my x is greater than 8. Oh, so that's the probability that x is 9 or 10 or 11 or 12 up to infinity, which is 1 minus the probability that I get my first 5 in the complement of that, which would be the first roll, the second roll, the third roll, up to the 8th roll. We have a cumulative function for the geometric, and as you already saw, so that's going to be the geometric CDF of N comes first. We're going up through the, P comes first. Success is 1/6. Then comes my N going up through the 8th roll. 8. So the probability of not taking more than 8 rolls to get a 5. It's going to be 1 minus geometric CDF 1/6, comma 8, and that's going to be about 23%. So and that one comes in handy a lot. Yes, sir. I put 1/6. Comma 8. I'm doing the cumulative again. And there is a little proof for the cumulative, which is a very simple function to do. without a calculator, and it's using a geometric series. If you need to look at a single value, when when it takes exactly 5 rolls to get my first one, exactly 5, then I use the PDF. If I want to think about getting my first roll of a 1 in either the first time I roll the dice, or the second time, or the third time, or the fourth time, or the fifth time I'm accumulating, that's when I use the CDF. What I would essentially all I'm going to be doing is adding up the probability that it happens on the first roll, or exactly on the second roll, or exactly on the third roll, and that little function adds all those up for me. Okay? I think that's enough.